Hello again. Welcome back to .NET Conf. I am Bill Wagner, and in this session I'm going to show you what's new in C# 7, in C# 7.1. And the way I'm going to do that is we're going to look through a bunch of the features, and we're going to do it by upgrading an application to make use of those. So let's go ahead and begin. Let's start with a feature overview of the different things that are new in C# as of version 7. The things that I am going to show you today is we'll look at pattern matching and tuples. We're going to look at the default literal, which is a C# 7.1 feature. We're going to look at task returning main methods, also a C# 7.1 feature. We're going to look at local functions in a couple different scenarios that I think you're going to want to incorporate into your code. And if there's time, I'm going to do a little bit of a forward-looking discussion into non-nullable reference types, which Mads showed in the keynote that will be coming with C# 8. Now that's not the full list of new features. Some of the other ones that are in C# 7 or 7.1 that I'm not going to discuss today are out variables, discards, ref locals and returns, more expression-bodied members, throw expressions, and some numerical literal expression enhancements. Now, the reason I'm not going to show those is that what I really want this particular session to be about is some practical advice to take your applications that you have now and introduce the C# 7 features into those applications. So what I'm going to do for the demo is I'm going to take two of our tutorials on docs.microsoft.com that walk people through some things that you can do in C# that were written as of C# 6. And I'm going to look at those and add features that make sense in those applications that came out in C# 7 and 7.1. Rather than trying to jam every new feature in, I'm going to discuss how and why you should add features into your applications that the language team has added. What we're going to end up with is the applications will be slightly smaller, a little bit more concise, and we'll add a few new features along the way. And we'll show you how you can leverage those new features in your applications in ways that are natural for what you're doing. So these features didn't make sense in the two apps that I want to upgrade today, but I want to make sure you know that they're there. And if you're not familiar with what these features do, what I want you to do is look at the build session Mads Torgerson and Dustin Campbell did from the 2017 build, where they do go through every single one of the features and explain what they're for and what they do. And then you can see when these features fit into your application. So the first demo I'm going to do, we're going to upgrade a couple things to C# 7.1. What I'm going to start with is an application that's one of our C# tutorials. I'm going to run this to begin with, and we'll start to look at the code, and then we'll go ahead and upgrade it to C# 7. This application is a tutorial that teaches people about LINQ, using what I think is a really fun little application that is based on a magician's technique. So magicians that work with cards have practiced a long time to shuffle cards very, very carefully and control the deck. So the key piece of this particular algorithm is I build some structure that looks like a normal 52-card deck, and then this query right here builds the deck, and then I go through a set of loops to take that deck and I shuffle it by interleaving every single card. So let me explain this visually a little bit, and it'll be easier to explain, then we'll go back to the code in a second. So what I would want to do as a magician is I want to cut the deck exactly in half, 26 cards on the top, 26 cards on the bottom, and then when I shuffle it, I'm going to interleave every single card. And by doing that, I control where every single card in the deck is. So I'm going to change which one I do, because there's two variations that a magician will use. One is called an inner shuffle, where the top and the bottom cards stay the same. And one is called an outer shuffle, where the top card from the bottom half becomes the top card in the deck. The reason I want to switch which one I do is the inner shuffle, which is the one we'll demonstrate here as we walk through and upgrade this application. It takes only 8 cycles to get back to the deck in its original order. An outer shuffle takes 26, and that's the one magicians will often really practice with. So I'm going to run the existing application just so you can see what the output is. It's a .NET Core app. It's doing its thing. It's going to fire up a console for me. And then right now it's doing a build. Build succeeds. And what this application does right now is it prints the order of every single card in the deck as it goes through all these shuffles. And then at different points through, it's going to say how many times it's already shuffled the cards. And you can see the cards start to move around a little bit. Things get in order, and so on and so forth. And then after 8 shuffles, it's done. Now, some of the feedback I had on this application is that it's kind of cool to watch, kind of cool to look at, but printing out the location of every single card, that's a lot of output, and it's really kind of hard to see what's going on. So we're going to add a couple features to that as well. But I'm going to start by simplifying some of the data structures that we have. So I'm going to start, there's a file here called the playing card. And I'm going to point out one thing to people who aren't familiar with our samples on docs. We do use regions, and we use them for a particular reason on our site. We pull the code directly from the sample to insert into the markdown files that you read as you're discussing and learning about the tutorial. So the snippets mark regions of code that we pull out and insert into the docs. That enables us to have a CI build on all of our samples, which then directly is reflected in the code that you see online. So all our samples get built and tested as part of our build process. So if you give us a pull request and give us a new sample or update one of our samples, please leave the snippets in place. So I want to change this to tuples because if we look at this particular type, it really doesn't do anything. The only code that does anything other than just initialize something is the override of toString. And honestly, I think I can live without that. So I'm just going to delete that file. And now I'm going to get one programming error because here in this query, where I create the starting deck, I now don't have that type anymore. So let's just change it to a tuple. Okay, there we go. And now I'm going to get this red squiggly because I'm upgrading to 7.1. And when I look at what that red squiggly tells me, it says predefined type system.value tuple is not defined or imported. Now when C# 7 first came out, I would need to go to NuGet, get the NuGet package system.value tuple, and add it to this application. Well, this application is about a year old. I wrote it when .NET Core was shiny and new in 1.0. So instead of grabbing that NuGet package, what I'm going to do is I'm going to go and update the application so that instead of targeting .NET Core 1.1, I'm going to target .NET Core 2.0. And after I make that update, system.value tuple is now part of .NET Core 2.0. I no longer need a separate NuGet package. Now this is an important concept to remember and to understand. As we move forward because of .NET Core, .NET Framework, Xamarin workloads, and so on, the framework and the language may rev at slightly different versions. And new features in the language may require new types. When that happens, and the language is a little bit in front of the framework, there'll be a NuGet package that you can add. When the framework catches up, we'll no longer need that NuGet package in our applications. So rather than adding system.value tuple as a NuGet package and keeping this on .NET Core 1.1, I'm going to take this opportunity just to move it to .NET Core 2. And now, right now, if I want to do just the 7.0 tuples, I would do something like give these variables a name so I can see the suit and see the rank. That just feels kind of redundant. So instead, what I'm going to do is I'm going to change the name of the range variables here. Move this out of the way as I zoomed everything in. Stop that. I think because of my resolution, I can't get that off my code, so I'm just going to type it myself. Fine. All right, so Change that to rank. And now, the only thing I'm not going to like is that what these are now going to be called. If I look at what's in the starting deck, if I say starting deck sub-0 dot, you can, looks like I will be picking up rank and suit as their names because I've automatically got the 7.1 compiler going. And now, go ahead and run, and we're running it with tuples rather than the built-in type. And you can see I just have slightly different output. I think I'm okay with that. I've simplified the app. I'm making use of a new feature. I'm good. For the rest of this demo, let's now upgrade this with some of the features that were requested. The feedback I got was that printing the entire deck was really kind of just too much. It was hard to figure out what was going on. So let's remove some of these. And what I want to do instead is I want to print just a sample of the cards that come out of each shuffle. So let's start. I'm going to define a method. And I'm going to say I want an enumerable of int, because if I'm only going to print out some cards, I need to also print out where they are. So I'm going to write a method that returns the index, indices of different cards. And that's going to be a method called findCard. I need to pass in a deck. And we'll start by finding all the aces. Or excuse me, all the aces. So I'm going to do rank.ace. So we'll print out just 4 cards. Find where all the aces are. Go over to this method, control dot. We'll generate that new method. Press F12. There we are in my brand new method. And the method definition, if you see, I now get that tuple, suit and rank, an array of tuples, my shuffle, and I'm looking for aces. It's an IEnumerable method. So what we're going to do is we're going to do a for index starts at 0, index less than the size of the array. And my test is simply going to be if the card at that index, if its rank is equal to the ace, well then we're going to yield return the index. Okay, so I don't really like those variable names. This is really just the deck. And as we add to this, I really don't want to call this variable ace. We'll call it the rank that we seek. And then after I've found the different cards that I want to find, let's write some of those out. And we'll use a C#6 feature for interpolated strings, where we're going to say the is at location index. I want to do that after each shuffle as well. Let's just add a blank line here just to point out that we're starting at the beginning here. And we'll shuffle them. After each shuffle, we'll print everything out again. Let's see how far we got on this part. And we missed one part there. And one question that's coming in as I do a build and just test this is, do I need to install .NET Core on a PC to do this? And Kathleen's or Scott's examples, as there is a .NET framework already installed on any PC. Yes, .NET Core is a separate thing that you install, as is the .NET Core SDK. If you install Visual Studio, .NET Core is one of the workloads that you can install along the way. If not, you can run the .NET Core installer separately if you want. The reason they are separate has to do with some of the design decisions for .NET Core. One key .NET Core feature is that the CLR and such travel along with the app. So if you want to install different applications on the same PC, if you use .NET Core, you can have different versions of the framework and the base class libraries running for that PC. Whereas if you're using .NET Framework, because it's a Windows component, all the applications will be running against the same target framework. Okay, so yes, if you want to do .NET Core things, you do need to install .NET Core as well as the framework. So far now we've got a nice little bit where we're looking at just where the aces are. We have a nice little sample there. All right, so let's expand this a little bit. So looking at just one thing is fine, but let's say what I really want to look at now, let's say that another thing we might try is I want to look for all the hearts. Let's start with the beginning one as well. And we'll change that to say I want to look at the hearts. I'm going to need to make some changes to my method because you can see I've got some compiler errors up there. Now I could write another whole method. I could start to really do a lot of different work and try to say, okay, so different overloads with different things that come in. And I can see where this list of feature requests is going to go. And I think that's going to cause me a lot of pain over time. So what I'm going to do instead is I'm going to leverage pattern matching, because really what I'm doing is if I want to find cards that match a certain pattern, looking for a particular rank or looking for a particular suit is basically a pattern. It doesn't rely on types, it relies on just some property or some set of properties about a card. So let's change this to an object that I'm going to call my filter. And then to make that first part still pass, I'm going to say if filter is rank, and we'll clean this up with a few sets of braces just because we know that that kind of stuff leads to bugs. And yes, I know I didn't use it inside. We'll clean that up at the end. So now I've tested that first pattern. And a couple nice features here in C#7 that we have is notice the is operator works on value types. Rank is an enum, just has those 4 values, clubs, hearts, diamonds, and spades. Or excuse me, rank has ace through king. And I can assign the variable as well as just test the is. So I test the type, and if the type matches, I'm going to assign it to a variable. Well, let's write the next one. Else, if filter is suit, what we're going to do is copy this for the moment. We're going to clean it up later as I introduce another C#7 feature. And here I want to look for a different suit, match the different suits. Okay. And now I've created a second pattern where I'm looking for suits in a particular part of the code. They're in a particular part of the deck. So we can try that. We're going to get a little bit more output, but you can see I see the locations where all the suits are. Now here you can see a few properties start as things start to move around the deck. You can see that they start to flip around. Pretty soon the 8's coming before the 2 and so on as they start to interleave back and forth in the deck. But that's a little bit more output maybe than we want. So we're going to add one more pattern that really shows how magicians and card sharks and con people play with this kind of technique. Since patterns really aren't based on types or aren't based on particular variables, but can in fact be based on anything that I want to test about a particular variable. Let's say I want to find all the face cards. So I'm just going to define this string constant to say I want the face cards. So that's going to be all the jacks, all the queens, all the kings. Those 12 cards out of the deck. Well now, okay, I don't have a case for that yet. So we'll add one more, else if filter is string S. Okay, that's close, but that's not really the pattern I want. I want another test. So let's add another set of braces here. And we're going to say and S is equal to face cards. Okay, again, nice feature of pattern matching. Notice that I've assigned the variable S as a type of string. And then I test equality here. Because of the short circuiting of the and operator, I don't evaluate if S is equal a face card unless the pattern matches. And when I do that, S is type safe and it has been assigned. I'm going to do one more copy and paste. Don't worry, we'll get rid of those as we add another C#7 feature. And here now we're going back to rank, and I have two tests. That rank has to be greater than rank.10. And deck subindex dot rank has to be less than rank.ace. So if it's greater than a 10 and less than an ace, it should be a face card. Cool. There we go. So now you're seeing Jack, Queen, King of clubs, diamonds, hearts, etc. And here's one of the tricks that card sharks can use. If we scroll back up, after the second shuffle, at a certain location in the deck are all the face cards. So if you deal from the right spot or if you cut it at the right spot, you get nothing but face cards for your hand. Really nice trick. All right, so I've added the features I want. But let's say that this code is a little bit uglier than I would like. In fact, it's really ugly on two different sets. First, we know where this is going as developers. We've now added a couple features, and we know there are going to be more. And in fact, one of the links that I'm going to give you at the very end of this talk is where this sample is. After I've upgraded the sample, if you have other ideas of filters you'd want to implement, go ahead and send us a pull request. I'd be happy to see that. So I'm pretty sure this if else thing is going to grow. Well, let's change that to a switch. So I'm going to switch on filter, and I'm going to have three cases. I'm going to have case, rank, rank. I'm just going to have a rank. We're going to have a suit. I'm going to break on that one, and I'm going to have a case string S when S is equal to face cards. Okay, there's some red squiggles there on rank, which we'll take care of as I remove some of the code that I'm going to be replacing to put inside here. So if it's a rank, well, now I'm going to move this code inside up here. If it's a suit, we move this part up inside that section. And if it is a string, we have this constant set of code inside there. All right, and then I can get rid of this if nested else things. So that's one of our other pattern matching syntax, is you can use a switch statement when you have a lot of different patterns and you're going to do different kinds of things. So now we have this loop here, and I still don't like this. We'll just run just to make sure I didn't break anything. Okay, looks like face card still. I don't like this because there's a lot of repeated code. You saw me copy and paste it. You probably felt bad. I did too. Let's fix that right now. If I look inside these for and if statements, the only thing that is different is that if and the condition inside that if. That looks a lot like something I can solve with a lambda. So we're going to go right here, and I'm going to introduce a lambda, then I'm going to make a func The things that I might be testing would be a suit, a rank, and I want to return a Boolean. And that's going to be a predicate. And just because I want to initialize it, I'm going to use the default literal and say, okay, it's going to be assigned this value, so it's definitely assigned. Before C# 7.1, I would have to do default open parens, func, suit, rank, bool. That's a lot of typing. I don't like to do a lot of typing, especially because that isn't going to help your understanding of the code. If I just put a semicolon here and say, yep, it's the default value, you can look at that and pretty much understand what it means. You know what its type is. And I'm going to click my little light bulb, and you see I have two options here. I can upgrade this project to C# language version latest or C# language version 7.1. So there's a new property that I'm going to show you in the second demo that I upgrade for language version that has a number of different versions that you can pick. So as Mad said Monday, C# 7.1 shipped with the latest upgrade to Visual Studio and the latest upgrade to .NET Core SDK. By default, it's turned off. By default, you're getting C# 7.0 behavior. The default is the latest major version. If you want to use the 7.1 features, that's under your control on a project-by-project basis, and you upgrade. Right now, I know I'm upgrading to 7.1, so I'm going to specifically pick 7.1. And as soon as I do that, you can see my red squiggles are going to go away. And now inside each one of these case statements, all I'm going to do is just say predicate equals. I'm going to take in, let's make sure I do these in the right order. I'm going to take in a suit and a rank. And I want to return rank equals the dec subindex dot rank. Actually, I did that in slightly the wrong order. I want to do that as that way. So I capture rank. Here where I have suit, we're going to say that the predicate is, it's going to take suit, we'll just say S and R, and what I want to test is that S is equal to the suit. And here my predicate is where R has to be greater than rank.10 and R has to be less than rank.ace. Let's add our parentheses in a few spots. Just to write that just a little bit clearer as we're typing. And you can see I cannot use S because S was the variable I assigned to my string. So I'll just change this one up here just so that we can keep these predicates a little bit consistent. Let's put back one of those loops. I'm going to copy the one loop down here, and I'm just going to say if predicate of dec subindex dot suit and predicate index sub index dot rank yield return index. So now I've cleaned that up noticeably a little bit more. I've now got just initializing that lambda just once, depending on which case I have. And each of the patterns initializes the lambda, and then I have the loop once. It helps me spot one bug, is we should probably have a default where we're just going to say predicate is going to equal, we'll just print out every card there. And we do that. We'll go ahead and run, make sure that that still works. And we're printing out the face cards again. So far, so good. So that was a fairly brief introduction to simplifying some code and adding some features between tuples and pattern matching and the new default literal. A couple of the keys about this for places to look in your code to leverage these features is if you notice that the type that I replaced with a tuple didn't have any behavior. It simply held values and had a two-string. Okay, I can do that with a tuple. I get a default two-string, but I was okay with that. It didn't have any behavior that I really cared about. Good opportunity to use tuples. And if you look, the feature that I added with pattern matching was because if you think of finding a few cards in a deck of cards, it's all based on patterns. We could add others here to say find the one-eyed jacks, find the red queens, anything else that might be part of a common game. Find the 7s and the 10s, whatever it might be. Find all the cards for a euchre deck if you're from the upper Midwest. Any of those are possible things you could add, but they're not necessarily based on type. They're based on different properties, not C# properties, but general properties or observable things about a variable. Pattern matching lets us switch or change branches based on anything about a particular object. That we can test types, we can test values, we can do compound expressions. It's a very, very nice way to do some of those. Now I'm going to upgrade one other application that has a very similar, it was written about the same time, and we'll show a couple of the other features that we can use in upgrading an application. Okay, this application is the teleprompter tutorial. So if I run this tutorial, what you're going to see is this application loads a text file and then writes out each word after a pause. So it's meant to be something like a teleprompter that you could read at a particular pace that you liked. If you want it to go faster, you can press the greater than key, and each time you press it, it'll speed up. If it gets too fast, you can press the less than key and it'll slow down again. Rather than read everything, I'm going to go ahead and just get it up to its maximum speed. Let this finish. And then we'll upgrade this one to C# 7.1. And the two things I'm going to show here is a couple very useful applications of local functions and our async main, or task returning main. So I'll go ahead and just stop that rather than watching it roll through. So if you look at our main, right now I've got a void main, and I wasn't even using all of the extra code that Mads showed on Monday with the get a waiter, dot result, and so on. And anyway, it's ugly. We don't want to do this. What I really want to do is we're going to make this a task returning method, and we're going to make it an async task returning method. And then I'm going to just delete this, because if you look, run teleprompter just calls, is right below and just calls the same thing. So now I have this async task main. Awesome. Looks like I did the right thing. Go ahead and do a build. And my build failed. And I wanted to show you this because if this is the first thing you do when you upgrade a project, the error might not be obvious until you think about it for a minute. So I didn't get any red squigglies on static async task main, which is good. It was one of the signatures that is supported. But I get this error that says, program does not contain a static main method suitable for an entry point. Now the first time I saw this, I had to think for a minute, what did I do wrong? Well, I didn't do anything wrong. I just haven't done something yet. The code that I wrote is valid, so the compiler doesn't give me squiggles. But because I'm using C# 7.0 or 6.0, or when I wrote it, async task main is not a valid signature. So everything compiles, and then when you get to the step where we're trying to find main, the compiler says you don't have one that matches. So I'm going to go into the properties page for this project. And first of all, we'll go ahead and update this to .NET Core 2.0. And then we'll slide over to the build page. And at the bottom of the build page, you're going to see this advanced button. And under that advanced button, we see our C# major versions. And before I change this, I'm going to make one change, is I'm going to say, I want this for all configurations. Because the way the UI is constructed, you can set language version differently for debug and release builds. And if you don't think about what you're doing, that's probably what you're going to do. And it's almost certainly not what you want. Most likely you want to use the same compiler version for both debug and release. So set the all configurations up in the build tab, open advanced, and here's the full list. So I want to show just a couple different points here. We have these two keywords, default or latest, to get the latest minor version or the latest major version. We also have every different version of the compiler that has been released and specified. So I can pick everything from the official standard C# 1, C# 2, 3, 4, 5, 6, and 7, and 7.1. So we'll just pick 7.1 because that's really what we wanted. And now, when I go back and I do a build, async task main works. Cool. So I wanted to show you that workflow just because it could be confusing the first time you see it. A couple other things about async main. So you may have learned that async void methods are bad. And you're right, async void methods are bad. If I change this to be async void as a main method, I get program does not contain a static main method for an entry point. The new feature for task returning main, so that you can use async, specifically disallows async void. So if you decorate a method with async and it returns void, you can't use that as your main method. And the reason is it can't be awaited appropriately by the code that gets added. So it has to be task or task of t if you had int. It has to be task of int. I could also make it a task of int. But if I were to make, say, task of string and return foo, the compiler will also tell me it doesn't contain a correct method. And now I get a warning that it has a wrong signature to be an entry point. So we'll just leave it as task since this one didn't and does not return anything in particular. So there is a little extra checks on main. It can't be any async method. It must be an async task or task event. Now, the other two features that I want to add is down here in a couple of the utility methods. Effectively, how this application works is it starts two tasks. One reads the file and writes it out word by word after looking at a delay and doing a task.delay for so many milliseconds. The other task watches for keyboard input to see if you've pressed either of the keys to change that particular delay. So, going back to, and I'll come back to some questions that are showing up that were on the first app. I'll come back to those in a bit. But if we look at this input, or these methods, I've got a couple different utility methods that can complicate error handling. So one of them is some async task returning methods. Now, I'll leave get input alone, but if I look at read from string, if we look at our show teleprompter or get input, if it would turn out that this config object is null, this is going to crash. It's going to do some bad things as soon as it tries to call config.updateDelay. So I'd like to do some checking there, and I would say if config equal null. Then I'm going to throw a new argument null exception. And I'm going to say name of config. Now, the problem with this, because it is an async method, is that what will happen is that exception will not be observed until the task is awaited. That makes things hard to debug. And the reason for that is the C# compiler builds this whole state machine around async. Bob Tabor is going to do some things on an async workout. We'll learn more about that in a session this afternoon. But what that means is you'll get back a task, and until you await that task, you won't be able to observe if it is running successfully or if it's faulted. When you await a faulted task, whatever exception faulted the task will get rethrown. That makes this kind of configuration very, very hard to debug. So what I want to do is I want to kind of remove that async modifier from my public methods, make this method that does all my error checking for parameters and invalid arguments or possibly invalid state on an object, and make that method synchronous. And then make it return a task that's created from an async method once I've done all that validation. Now I could do that before, but that would introduce a new private method. It kind of makes everything a little bit bigger. It bloats the space of your class. And I really only intend for that internal method just to get called once. So instead, I'm going to write a local method, and what I'm going to do is I'm just going to say return get input impl. And now I just have to define that. So that's going to be an internal async method or a local function. It's async. It's going to return a task, and it's get input impl. And it's going to do the work that really is async here. So I'm going to make an async task returning method that creates this thing I'm going to start and awaits tasks.run. Now you see I get a red squiggle here, and what it's telling me is this is an async method. It returns a task. Okay, that's what I wanted to do, but I still have that async modifier. So I have to remove the async modifier. And now what would happen is if I pass null to get input, what I'm going to see is an exception happens immediately. So I can catch that programming error immediately without wondering what happened when I await a task later. And then I have a local function that's kind of just hidden inside this get input method. So it doesn't show up as one of my members, public or private, and it's easier to spot my intent that I only expect this to be called from inside that task returning public method. Now, I have a very similar pattern right here in the code that reads from the text file, except that it's an IEnumerable. And an IEnumerable does the same basic kind of work. It's going to do yield returns when you ask for any of the elements. So once again, you can call this method and no errors will be returned, no exceptions thrown, until you advance the enumerable and want to call for the first item. So let's come back and let's do the same thing here. So I want to say is if string.is null or empty. I'm actually going to say if string or white space of file, then we're going to throw, and I'm just going to throw an argument null exception. And before I check this code into our repo, I'm going to do a few little bits of cleanup to make it a little bit nicer to check both null and white space, because white space really isn't null, but it's still bad. And then I want to return a read from impl method. And now I have to define that again, and that's going to also be an IEnumerable of string, read from impl. And that's going to declare the string, do all the usings inside of it, so on and so forth. Let's make sure we pick the right brace. And again, same basic pattern. Forgot my new. Okay, so now we've cleaned this up using a little bit of local functions. And that pattern is basically when you make one of these methods where the C# compiler is going to generate some code for you that defers when errors are observed. It's often nice to wrap that in that implementation and use that state machine for either IEnumerable or for an async method. Wrap that in a local function and have an outer method do all your argument and state validation. Throw errors synchronously so they can be very quickly caught and observed exactly where you're calling the method. And then defer to the iterator method or an async method that is a local function so it doesn't have scope from anything outside of the method where you declare it. So we'll go ahead and run. And as long as I can type correctly, we should have everything working exactly the same way. We can still see our console apps. Push this together, and we'll run that at its fastest pace. So now we'll go ahead and just stop. So there's a few features from 7.1. So I'm going to lead back. One of the questions that came in was I was working on the first demo is, why is it important to assign that predicate to default? I could just assign it to null. I sort of got in the habit of using default more when there were more, some things were structs and, or possibly, especially with generics where some things may be a struct or it may be a class, and null won't work for a class type. So I'll often use default. Other places where we can use that default without the full type could be argument or other areas. So admittedly, that's probably the one part of the demo where you don't necessarily need the new feature, but I still kind of liked it. All right, so that's upgrading some things to 7.1. So now I'm going to spend my last few demo minutes doing something similar to what Mads talked about Monday, where we have non-nullable reference types. But I want to address a couple of the questions that came in after Mads talked, and I'm going to show that same preview, but I modified Mads' demo a little bit. So what we're going to do is I'm going to talk about some code that hopefully maybe you've written, especially if you take care in how you write different code. I'm going to start Visual Studio while we chat about this. Hopefully most of your code is going to do things that where you test for null anytime that you work with it, because then you'd be better than most programmers out there. So I will open up the preview that I wrote that I updated some of the code. And what I did is I took Mads' person demo, where he looked for Miguel's middle name, which didn't really exist. And I made a couple changes to it so that null is never valid. And in fact, with static analysis, we could check and make sure that null never actually happens. So I used an initializer here on the, let's make the code just a little bit bigger. An initializer here for the middle name property so that it's initialized to NA. And then I'll only set it to something if non-null, something non-null gets passed into one of the constructors. So you can see I did a, for checking the middle, I have a if not string is null or white space, middle is middle. My other one where I send it in, I sent string.empty, which is not null. I probably should update this to pass in that value of n/a. And if you notice as you look through this program, even though I have the preview where we have the non-nullable reference types in it, there's no warnings whatsoever. I don't have a single squiggle. Now, that's important for the design of this feature and what it means for your code. Part of the reason for saying that our normal types, string, some object, anything that you define that's a class type, without that question mark operator would be a non-nullable reference type, is to encourage its use. If the language design went the other way and you had to annotate types, there would be a tremendous amount of work to get to this world where null isn't a valid value for a type. So there was a strong desire to make your existing code suddenly become non-nullable reference types. And then the rest of the syntax really followed from that really big goal, so that let's be as nice as we can and help you find places where you may actually have a mistake that could cause null reference exceptions, because we know they happen. I made some modifications to this, which is, all of 45 lines, including some of the white space. And we could look at it and prove that null can't get in. But as soon as I make one change, now I am going to start to see I can't convert null to a non-nullable reference. Okay, well now I have to start making a few changes. I put a question mark there. Okay, and if you note, now I've gotten rid of most of these because here, interestingly, we didn't explicitly check just against null. So if I just went if checking just against null, there it goes. If I left it in here, which still works, I get my errors here, and then I have to just go add the damn it operator, which this is still really new, so I'm not sure exactly where it goes. I have to think about it myself. Okay, so the idea is, if your program is really well formed, hopefully you don't have anything to do. If static analysis says there are things that may be null, you might have some work. Now this particular idiom here where we're checking is null or white space may be taken care of by the time everything gets revved out, because the static analysis on BCL types might get better. But the goal is by turning this on, where your code is already correct, you shouldn't have anything to do. Where your code may have null reference exceptions, there might be some work. And again, very early preview, definitely a lot of work still to do to get this even up to where the straw man is, and see what kind of feedback we get and what kind of reaction we get. So that's really the idea behind the feature, is to help find problems and bake finding those problems right into the language. So with that, let's sum up on what kind of things that we've worked with. Here's a whole bunch of resources. This would be the screen you take a picture of, or pause, look at it, and save some of these links. 2 articles on docs.microsoft.com for what's new in 7.1. The 2 tutorials I updated while we were working. Over the next couple weeks, I will put a PR in to introduce the code that you saw here today. The C# guide, docs.microsoft.com, .NET C#, everything about C# on docs.microsoft.com. Akka.ms/non-nullable, that is the straw man proposal for non-nullable. Comments are welcome. C# language, that repository contains all information about different features that are being proposed or implemented for future versions of the C# language. It's a good one to get familiar with, look at, and you can see what things are being discussed. The language design note meetings are there. Specs for new features are there. Status of the new feature implementation or proposals are there. Have fun. And lastly, github.com/.net/docs. The code that I worked with today, at least the starter, is already there. I'll be opening up a PR with these fairly soon, and you'll be able to get the code that I'm working on. One person from the community found a couple interesting optimizations in the card shuffle algorithm, and I have a couple PRs from him that I need to review and merge before I put my C# 7 version up there. And I'm really grateful for him to add that and to give us that contribution. And again, for you, it's open source. We want your feedback. We want your updates where you have them. And we want what you can add for us. And with that, what I want you to do is look at your applications, and as you're coding, start thinking about these new features if you're not using them yet. Where appropriate, as I did today, add those features into your application. You don't have to make it a task that sits on your Scrum board and we have to update everything and add all these features immediately and rewrite my app. No. As you code now, start to develop those new habits. As you're doing some refactoring, Maybe update some things to make the code smaller and more concise. Adopt those new features where they increase productivity for you on your applications. That's what we want to do for you, is to make you more productive. And relax. Like I showed on that non-nullable, backwards compatibility is very important, and we're going to do everything we can to not break code that's working, but help you find errors that might be escaping your vision right now. And get involved. Some of the links that I had are for our public repos, where we invite comments, we invite discussion, we invite new issues and new ideas, and we value contributions. And with that, thank you very much, and I hope you're enjoying .NET Conf, and have fun.